So I want to add some more information with regard to correlation and covariance. So there's the concept of an efficient portfolio where you maximize your return for a given volatility. So now that we understand how to calculate the expected return and volatility of a portfolio, we can return to the main goal, and this is the main goal of this chapter. And the main goal is an efficient portfolio. So we determine how an investor can create an efficient portfolio. Okay. So let's start with a simplest case: two stocks. All right. So basically, we have two stocks, Intel and Coca-Cola. Here's the expected return and volatility. Right. So now if we combine them, let's combine them. So individually, here's their expected return and volatility. If we combine them, basically, right, let's assume we have weights here of 40% and 60%, right? So suppose an investor believes these two stocks are uncorrelated and will perform as follows. So let's compute the expected return and volatility for different combinations. So we start out with a 40% invested in Intel and 60% in Coke. So here's the expected return. Here's the weights, and here's the given returns. So the expected return, right, is simply the sum, or 14%. Now let's compute the variance. And we saw the variance from equation 11.9, right? So here we do the variance. All right, so notice in the variance now you need the correlation, right? Here. So you got to calculate that the correlation, and basically that'll give you basically the variance of the portfolio. Once you get the variance, we can simply just take the square root, and we basically have the standard deviation. So the standard deviation on the volatility is 25% in this case. The equation 11.9 that was used to calculate the variance, and you'll notice here's the correlation, okay? And basically, to get the correlation, as I said, we have to go back and let me look for that equation for you. So here is the correlation, okay? And the correlation is, again, is derived off the covariance. So equation 11.6 is the correlation, okay, that we used in that example, okay? So let's go back to that example. So here's where we were, right? Here's where we were, and basically we had to calculate the correlation, which is what we did using that, I think, equation 11.6, and that gave us the variance, right? That gave us the variance off of this. So we used equation 11.9 for this. So here is the volatility for different weights. So here they solve it for different weights. So here's two stocks with different, and they're weighted differently, and the expected return and the volatility are calculated here. All right. So due to diversification, it is possible to find a portfolio with an even lower volatility. So here's the volatilities, right? Now you'll notice this is the lowest volatility right here than either stock. So investing 20% in Intel right here and 80% in Coke has a volatility of only 22.4%. But knowing that investors care about volatility and expected returns, we must consider both simultaneously. To do so, we plot the volatility and expected return of each portfolio in equation 11.3. All right, so here's what's known as an efficient portfolio. This is volatility versus expected return. So here's the volatility. So here's the expected return. So you'll notice here, if you have a trade-off between volatility and expected return. If you want the highest expected return, here in this case, you're going to use Intel, but you're going to have a higher volatility, okay? Over here, you're going to have a 10% expected return, but you've got 20% Intel and 80% Coke, and over here you have 80% Coke and 20% Intel, all right? I mean 80% Intel and 20% Coke, all right? So this will give you basically the different portfolios depending on your level of volatility as far as returns. So as long as you have basically more than 20% invested in Intel, you'll notice you're going to get a higher return, but with the chance of getting more volatility, okay? So anything on the blue is inefficient, right? Because you're going to see you're getting more volatility and less return here, okay? So in this case here, when we had 80% Coke, from that point on, you can see here that anything along here is efficient enough to get an expected return, but again, at the cost of more volatility, okay? So the important point here is it makes the investor better off in both ways here, right? Suppose the investor considers investing 100% in Coke, as we see from equation 11.3. Other portfolios, such as the portfolio with 20% in Intel stock and 80% in Coke, make the investor better off in both ways. They have a higher expected return and they have lower volatility. So that's right here, right? As a result, investing solely in Coca-Cola is not a good idea, right? So here's 100% in Coca-Cola. So as we see here, this was the inefficient portfolio. You get higher volatility, okay? You get higher volatility for less return. So you can see the efficient portfolio is the red portion here, all right? So we say a portfolio is inefficient whenever it is possible to find another portfolio that is better in terms of both expected return and volatility. So looking at figure 3, a portfolio is inefficient if there are other portfolios above and to the left. And we see that in that diagram, right? We see that diagram, is right? And basically the heat claims to the northwest, all right? Investing solely in Coca-Cola stock is inefficient, and the same is true of all portfolios more than 80% in Coca-Cola. So if you see, if you have more than 80% in a Coca-Cola here, it's inefficient, okay? Inefficient portfolios are not optimal for any investor seeking high returns and low volatility. All right, so now moving on to efficient portfolios. By contrast, portfolios with at least 20% in Intel stock are efficient, the red part of the curve, right? So we see this is the red part of the curve here. All right. There is no other portfolio of the two stocks that offer a higher expected return with lower volatility. But while we can rule out inefficient portfolios as inferior investment choices, we cannot easily rank the efficient ones. Investors will choose, and this is the important point. Now it's up to you. Investors will choose among them based on their own preferences for return versus risk. For example, an extremely conservative investor who cares only about minimizing risk would choose the lowest volatility portfolio, 20% Intel, 80% Coca-Cola. And an aggressive investor might choose to invest 100% in Intel stock, even though that approach is riskier. The investor may be willing to take the chance to earn a higher expected return. All right. So here's the a nice example, and you could go over this example here and see how they solve it. It's good practice. Excuse me. All right, so now what effect does correlation have? Correlation is real important. When we looked at figure 3, right, we assumed that the returns of Intel and Coca-Cola are uncorrelated, right? They're not, one doesn't affect the other. There's no risk that's common to both. Let's consider how the risk and return combinations would change if the correlations were different. Correlation has no effect on the expected return of a portfolio. Okay? And this is an important statement. It has no effect on the expected return of a portfolio. So let me highlight that in pink here. For example, a 40-60 portfolio will still have an expected return of 14%. All right? However, the volatility of the portfolio will differ depending on the correlation, as we saw in section 11.2. In particular, the lower the correlation, the lower the volatility. Okay? So you can clear, and we understand that, right? The lower the correlation, the lower the volatility we can obtain here. So that's where a correlation starts coming in. In terms of figure 11.3, as we lower the correlation and therefore the volatility of the portfolios, the curve showing the portfolio will bend to the left. So you can clearly see the required return isn't changing, but it's bending to the left to give you lower volatility. All right, so this is important. So you can see in figure 4, here's correlation +1, and here's the extremes correlation -1, and everything in between is pushing it toward the left. Okay? So the lower the correlation, the lower the risk of the portfolio. So here's the extreme cases, right? And here's the extreme, and then I guess it's 0 and plus a minus 0.5 here. Okay, between Intel and Coca-Cola. How the correlation goes. So when the correlation is less than 1, however, the volatility of the portfolio is reduced due to diversification. So you see that. So that's how the curve is bending toward the left. Okay. The reduction in risk and the curve bending become greater as the correlation decreases. All right, so that's an important point here, as the correlation decreases. At the other extreme of perfect negative correlation, blue line, the line again becomes straight, right? And here's the extreme, right? Reflecting off the vertical axis. In particular, when the two stocks are perfectly negatively correlated, it becomes possible to hold a portfolio that bears absolutely no risk. In real life, this doesn't happen, all right? In real life, this doesn't happen. So I just want to make that point. There's always going to be risk. Maybe minimal, maybe you're minimalizing it, but there'll always be risk. All right, so there's an item called short sales. A short sale is, as in GameStop, is you sell stock you don't own if it's high in price, and then you basically buy it back, assuming you're speculating that the stock is going to go lower. So that's called a short position. It's a transaction in which you sell a stock today that you don't own with the obligation to buy it back in the future. And you're all aware of what went on with GameStop, right? So here's an interesting example. Expected return volatility with doing a short sale. So you can see how they do a short sale. And here's the portfolio weights of Coca-Cola, and I believe it's Intel again, right? Coca-Cola and Intel, and here's the weights showing the short sale here, right? So you short sell 10,000 worth of Coca-Cola. Note that the portfolio weight still add up to 100%, right? They always have to add up to 100%. And basically, here's the expected return using equation 11.3. And here's the volatility to standard deviation equal, okay, using equation 11.8. All right, so this comes out to 36% and this comes out to 76. So short selling increased. Now, this is why people short sell, right? It increased the expected return of your portfolio, but also the volatility. So this is why it becomes dangerous, right? You make money, but you take on more risk. So he goes on and tells you how short selling is profitable if you expect the stock's portfolio to decline in the future, right? A stock's price, I'm sorry, not a portfolio, a stock's price. As you are all aware with, as I said a couple times, GameStop. All right, so here's the curve, all right, of the different volatilities, different percentages of short Intel, long Coca-Cola here, right, and again, short Intel, long Coca-Cola, long, and then you notice that this is right here. It starts becoming profitable, right? Not at this point, but from here on it does. Here it's not, right? You can see that. So and then the red, it takes off. Here you are, long Intel and short Coca-Cola here. So labels indicate the portfolio weights, Intel and Coke. For Intel and Coke, red indicates efficient portfolios. So these are efficient. Blue indicates inefficient portfolios. The dash curves indicate positions that require shorting either Coke, red, or Intel blue. Shorting Intel to invest in Coca-Cola is inefficient, right? And we see that here, right? Right? Shorting Coke to invest in Intel is efficient and might be attractive to an aggressive investor. So only here is where you start to see it, though, become a solid blue. So you start moving on the way up. You start getting higher return, and then it picks up from there. All right, so I just want to make that point that that's possible to do with short selling, okay? All right, so let me see if there's a video here that I can add to this because I don't want to go too deep into this. All right, I guess that's it. I thought maybe they would have a nice video in the book to, you know, to add to what I was saying, but I guess not. That was the only video for this chapter that we went through. All right, everybody, I hope you're well.